Welcome to Taxonomy Online. We are now taking implicit differentiation. We want to differentiate implicitly. Now, if you have a function, previously we have been seeing y equals to x, 2 plus x, this. So in this case, we have the independent variable, we have the dependent variable. We can easily make one in terms of other, or we can easily express one of the variable in terms of the other. But if in case I have x squared plus y squared equals to a value, you can see that I cannot easily express one in terms of the other. So I am going to differentiate this implicitly, meaning I will differentiate the y with respect to x and differentiate x also with respect to x. So if you are doing this kind of differentiation, then we say we are doing what? Implicit differentiation. It could also be, let's say, 3xy plus y squared equals to 3xy. If I have something like this, or let's say squared, since I cannot express y in terms of x, or I cannot express x in terms of y, I can say that this function is an implicit what? Function. So for example, if I'm asked to find if I have x squared plus y squared equals 0. Now, if you are doing implicit differentiation, the step is that 1, you are going to differentiate each of the terms separately. When you are done differentiation, then you make dy dx the subject. Alright, so I am going to differentiate this, and that is going to be the constant, which is the exponent is coming to multiply. So I'll be having 2x squared minus 1, and that will become 1. The actual sense is that it is x dx. I am differentiating what? X with respect to x. So you multiply the 2x by what? Dx dy x. You know you can cancel. Alright. Plus, if I differentiate this, it's going to be 2y as in differentiation. 2 is multiplying. We reduce the power by 1. Now we are differentiating this, which is going to be dy with respect to what? The x equals to, if I differentiate this, I get what? 0. So if you differentiate the constant, you still get 0. So now when you perform your differentiation singly or separately, now the next step is to make dy dx the subject. So we know this is nothing but 1. So we are only interested in this. So we are going to have 2y dy dx equals to the whole of this crossing the equal sign to give us minus 2x. The attention is on this. So we keep it by dividing both sides by the coefficient. So I have dy dx now equals to minus 2x over what? 2y. And I believe we can cancel out. So our dy dx is just going to be minus x over what? Y. So if you are doing differentiation whereby you cannot express one of the variable in terms of the other, then remember we are doing implicit differentiation. It is also not automatic to add this. We are adding this to bring the idea why we are adding dy dx to the differentiation of what? Y. Because if we are doing this, all the differentiation we are doing it with respect to x. So if I differentiate x with respect to x, it will be dx dx. If I am differentiating y with respect to x, then the value will multiply dy dx. Then I will make my dy dx the subject. Then voila, your answer is secured. Alright, thank you for watching. Don't forget to subscribe to the channel Taxonomy Online Mathematics. See you in the next episode.